Alright, so section 8.7 deals with complex numbers, which primarily involves the use of I. And I is this number that mathematicians came up with that equals the square root of -1. Now the reason that mathematicians invented this number is so that we could work problems like the one that we have below here. Because normally you cannot take the square root of a negative number. But if we create this imaginary number called I, we can do these operations. So we're going to use the same principles that we have so far for radicals and breaking up numbers underneath radicals. So we're going to break up this -64 under the radical into -1 times a +64. And we're going to do the same thing with our -16 in the denominator. We're going to make that -1 times that +16. And now that I have these broken up into two numbers multiplied by each other, I can split those into two separate radicals. So now I've got the square root of -1 times the square root of +64. And on the bottom, again, square root of -1 times the square root of a +16. And now I can work this problem. Okay, because I can replace each one of these square roots of -1 with I, and I can work these out normally, just using my calculator. So on top we have that negative sign, which doesn't change. I'm going to replace my square root of -1 with an I, and that square root 64 is equal to 8. Now on bottom, I've got, again, another square root of -1, which is another I, and then I've got a square root of 16, which is 4. Okay? And I is just like anything else. If you've got one in the numerator and one in the denominator, they cancel. So my answer to this is -8 over 4, which, if you break that down, is just -2. So there's example 1. I've got a couple more examples that I'm going to work from this section. Alright, so example 2 is demonstrating multiplying complex numbers, and it's specifically going to demonstrate the property of conjugates. Now, conjugates in complex numbers is the same thing as just the opposites. So these two terms are conjugates because these numbers are the same, just the sign is different. Okay, so let's look at what happens when we multiply a complex number by its conjugate. So I'm going to, again, use FOIL, first, outer, and last. So I've got 4 times 4, which is 16. And then I've got outer, which is 4, times that -9i. So I have 36i, 4 times 9. And then inner, we've got a +9i times a 4. So we've got now a +36i. And then I've got a +9i times a -9i, which gives a -81i squared. Again, I like to think of the i's as x's, as variables. You manipulate them and work with them the same way that you do variables. Okay? So, if we look at this, now we can see that these terms in the middle drop out. Okay, so we're going to be left with 16 minus 81i squared. Now, if you remember, I is equal to the square root of -1. Therefore, I squared would be the same thing as the square root of -1 squared. And if you square a square root, it just takes the root out. So I squared is equal to -1. So I can replace this I squared here with a -1. So now I've got 16 minus 81 times a -1. Well, this negative and this negative would get multiplied together, and that gives us 16 plus 81, which is 97, which is a nice whole number with no I involved. So whenever you multiply a complex number like this by its conjugate, you should always get an integer out as your answer. Okay, so that's example 2. I've got one more example from this section I'd like to do. Alright, so I'm going to illustrate how we can use that conjugate property to rationalize the denominator when we've got a complex number involved. Now again, we have to rationalize a denominator that has an I in it because, you recall, that I is equal to the square root of 1, a negative 1, I'm sorry. So, and we cannot have square roots in the denominator, so we have to rationalize it. We have to get that I out of there. And as I just demonstrated, if you multiply this number in the denominator by its conjugate, what you'll be left with in the denominator will be an integer. So I'm going to do that. Again, the conjugate of 2 plus 3i is 2 minus 3i. And whatever I multiply by on the bottom, I also have to multiply on the top. Okay? So, let me erase this real quick, just in case I need the space. Alright, I'm going to start with the numerator here. So we've got 2 times 2, which is 4. 2 times negative 3i, which is a negative 6i. Negative 3i times positive 2, that's another negative 6i. And then negative 3i times negative 3i, which gives us a positive, again, negative times negative is a positive, 9i squared. Okay, and that's going to be all over the denominator, which will look very similar, but with a different sign in here. So we've got, again, we start with a 4. We've got 3, oh, I'm sorry, that's not, I need to do outer next. And then 2 times negative 3i, which is another negative 6i. And then we've got the 3i times positive 2. So this time we've got a plus 6i. And then we've got a 3i times a 3i, which would give us a negative 9i squared. Okay? And again, these terms in the bottom cancel, because we've got a negative 6i and a positive 6i. So in the denominator, I'm left with this 4 and a minus 9i squared. And again, I can replace this i squared in the numerator and in the denominator with a negative 1. So I'm going to start condensing stuff down. In the numerator, I've got 4, and I've got 2 negative 6i's, which becomes negative 12i, and then plus 9 times a negative 1. And I'm replacing that I squared with the negative 1. In the denominator, I've got 4 minus 9i squared, and again, I'm replacing that with that I squared with a negative 1. Okay, now if I simplify this down a little bit further, I have this 4 and this negative 9. So 4 minus 9, negative 5, minus 12i, all over 4 minus a negative 9 is a positive 13. Okay. And just be forewarned, this is a perfectly acceptable answer, but your book, for whatever reason, likes to split this answer up into 2 fractions. So it makes this a fraction, and then this a fraction. So another way of expressing this answer is negative 5/13 minus 12/13 I. Okay, but this answer would be perfectly acceptable to me on your homework. Okay, and that's all I have from this section. Please let me know if you have any questions on 8.7.